Hello, I'm Professor Matthew Schmidt, and this is Genetics. And we're going to continue our Mendel Revisited sessions. And this one actually could become extremely long and detailed. Um, it very much depends on your particular course whether this issue is going to be addressed very, very quickly and vaguely or in a lot of detail. I'm going to basically give you just the basic idea of genes and the environment. And as I said, it could be a ridiculously long thing, but I think it'll suffice to get the idea across. And why is it part of Mendel Revisited? Well, because again, what have we been doing for these last few sessions? We've been looking at all things that came out not quite as predicted, and then looking back and saying, gee, so this must be what's going on to allow this to go into accord with what Mendel said. Well, this is sort of in that same general idea. Sometimes things don't come out as planned, and in this case, it's not for purely genetic reasons. It can be for environmental reasons as well. So, put it this way, everything we've seen so far, we didn't even talk about the environment really. If you're big P, little p, I mean, you have a big P allele, purple flowers, that's it. You're little p, white flowers. A lot of the times in real life, it does act as simple as that. But it would be really missing a big point if we left out the whole idea of the environment. Now, the term environment in this concept is a little different than, if you take environmental science, it's a lot about, I don't know, the wilderness and, ecology and things of that nature. But when I say environment, you're going to see there are various meanings to it. The bottom line here is it depends a lot on the trait, but just because you have a particular allele or a particular configuration of alleles, that does not necessarily guarantee that you're going to exhibit a particular phenotype, because genes, well, first you could say organisms don't live in a vacuum. We're always interacting with our environment. But there's even an internal environment that genes are interacting with. We'll talk about that in a moment. So, well, we'll talk about it right now. The external and internal environments interact with gene products. And you could almost make a little equation and say that gene plus environment equals phenotype. There is an actual more technical type of equation for this, but I just want to give you the idea. So let me give you a completely idiotic example, but you'll get what I mean. Human height is genetically determined. So I'm never going to be 6'5", no matter how much I want to grow or stretch myself, it's not happening. And most people grow to whatever height they grow to, and it's for genetic reasons, right? Well, say I did have the genes to be 6'5". Get ready, because it's dumb, but you'll get what I mean. If somebody, when I was 10 years old, cut my legs off below the knee, I'm not being 6'5". Now, while that's sort of silly, it illustrates that some environmental force, in that case it was a rather drastic one, interfered with the action of these genes that sort of wanted to, be 6'5". They're still doing their thing, but something happened that did not allow this phenotype to come to fruition, if you want to think of it that way. Now, while you might think that example is a bit off the wall, it goes to show that there are environmental things going on that affect the phenotype. Let me give you another example. I'm just making it up, but you'll understand. Say with Mendel's peas with the flower color. Imagine, of course, there are nutrients that are ultimately the precursors of everything that an organism can make. So I'm making up a little pathway here. Say that the P allele, just for the sake of argument, the big P allele, actually is an enzyme that takes some nutritional precursor and converts it into a purple pigment. Great. But what if there was a situation where the plant was malnourished and for whatever reason that initial precursor that it gets from the ground is not present? It can be big P all at once, but if it doesn't have that substrate, it's not going to be able to convert it into the purple pigment. And thus, it's possible that a big P plant could look white if it wasn't able to make that pigment. So I hope you're getting the idea. Now, two terms you definitely should be aware of are penetrance and expressivity, excuse me. And they both have something to do with the environment. You can't always know exactly what or how, but here's the idea. So penetrance refers to the proportion of individuals with a given genotype that actually express the phenotype that they're supposed to. So in other words, say we did a cross and we predicted that a quarter of offspring should show a trait. In other words, it would be like a 3-to-1 ratio type of thing. But when we looked at it, whether it be a family history or, whatever, however we analyze the data, we found that only 1/8 were actually exhibiting that phenotypic trait. Then we would say that this trait under these circumstances is exhibiting 50% penetrance. All right, so sometimes, by the way, if you see some of those human pedigrees and you're trying to figure it out, a lot of times just to cover themselves, they'll say, by the way, assume complete penetrance, meaning if somebody's shaded in, or I should say, if someone has the genes, they're going to be shaded in, they're going to have the trait. We're not addressing the concept of penetrance there because it could make it get very, very complicated. So in that case, I can't tell you why, but half of the people who have a particular genotype, due to some environmental factor, because what else is there, are not expressing that genotype. Now, it could be something we've already covered. I mean, something to do with the gender or etc. And that may not seem like the environment to you, but hold on for a minute. Let's go back for a minute and see what I mean by internal environment. So most of us, I understand, when you think of the environment, even in the examples that I gave, someone hitting you with an axe or some nutritional problem, that's usually what we consider the environment, and that's the external environment. But in a multicellular creature like ourselves, especially animals, from the gene's point of view, anything that it interacts with is its environment. So just as one example, steroid hormones are big gene regulator type molecules. So whether one's a male or a female certainly will influence the expression of certain genes, regardless of whether you have it or not. We talked about this with respect to male pattern baldness as an example. So that's considered an environmental influence as well. Now back to expressivity. Expressivity reflects the extent of a phenotype in a given individual. So this isn't a one gene trait, but Down syndrome certainly is a genetic condition where you have an extra chromosome 21, right? But the point I want to get across here is that there are people with Down syndrome, some of which are extremely high functioning, don't have a lot of health problems, and unfortunately some which have a good deal of mental impairment, shall we say, and often they do have a lot of health problems or prone to infection, etc. So you got Down syndrome, but the extent to which you have it is the expressivity. Why? Again, we may not always know, but the assumption is that some environmental factor is playing a role here, whether it be internal or whether it be external. It's always possible that there's some other genetic interaction going on that we don't know about as well, but there's enough documentation about environmental influences that we either at least need to consider that in these type of situations. So definitely know the terms penetrance and expressivity and understand how to apply them. Okay, so I've said all of this, well, I said a lot of this already, so I just want to make it clear what I mean by the internal environment. So literally from the gene's perspective, if a hormone comes and has to do with gene expression, that's an environmental influence. And if you're a male, just as an example, you have testosterone. I'm not saying women don't have any, but they have a lot less. So gender, as I mentioned, steroid hormones in particular, the whole way that they work is by affecting gene expression. So I say this not to be in any way gratuitously crude. It's just an interesting, we actually said something like it before. Both men and women have the genes necessary to make a structure that's usually gender specific, like a penis or ovaries, right? But those genes are not expressed depending on what they are, or they're not expressed depending on what hormones are present. Normally, we've said that the male root is spurred on by testosterone production, which turns on a whole bunch of genes that are all saying basically be male. And in females, you obviously have steroid hormones affecting other genes. So that's the environment of the genes just as much as the outside environment is. So the external environment consists of things like what's the temperature. Temperature can greatly affect phenotype depending what it is. We discussed nutritional circumstances, whatever it is out there that can affect gene expression. Now, interestingly, and we really can't spend a lot of time on this. I could spend about 8 hours on it, but we just want to get the idea. So in humans, we're different. We're animals, but we're different than most. It also includes societal influences and also our own thoughts. And this leads to controversy with regards to certain so-called complex behavioral traits. So I'm going to give you more just the idea of the controversy than try and give you any answers about them. You've probably heard of the whole idea of the nature versus nurture debate. And what this basically means is, it means this: there's controversy over whether complex traits have a genetic basis or whether they're almost purely environmental, or maybe both are going on. So a couple of ones, we've already discussed height, right? Height's relatively simple. There is a genetic determinant of it, but you have a potential to grow to a certain height. It may or may not be realized. I gave examples of poor nutrition, accidents, even with the respect to the internal environment. For example, pituitary dwarfism has to do with an imbalance of growth hormone, not allowing the genes to be expressed properly. So that's one thing. It gets complicated, guys. I don't mean to go into controversial territory, but these are things that you may need to think about, and they are things that need to be discussed. So alcoholism and certain psychiatric disorders, I'm not necessarily putting them all together into one thing. It's a complex topic. But on the one hand, there is some evidence that alcoholism, bipolar disorder, depression, anxiety disorders, initially it was thought that they were genetic because they do seem to run in families. And subsequently we've been able to identify certain genes, far from understanding it completely, that contribute to these type of conditions, or whatever you might say. On the other hand, it's not 100% clear that you got this gene, that's it, you're going to have this outcome. It's thought that there's some genetic basis. For example, I know it's a very sensitive topic, but with alcohol, you may very well have genes that give you a predisposition, they usually say, to becoming an alcoholic. I'm not saying it's easy, but the fact of the matter is you don't have to drink alcohol. So the idea that I'm a little nervous discussing it, to be honest with you, but the idea that alcoholism is a disease, well, in a certain sense, it certainly is a condition where people react to alcohol in a different way based on their genetics and biochemistry. But since we are humans and we have free will, it's possible to overcome that state, whether you want to call it a disease or not. The bottom line, though, guys, is it's pretty clear that there's probably a genetic element as well as an environmental element. And in that environmental piece, all sorts of things are going on. The way you're brought up, the thoughts that you have. I mean, this may sound dumb, but what if you had all the genes to be an alcoholic and you lived in a place where there simply was no alcohol? You wouldn't even probably know anything about it, right? So it's really thought that probably genes plus environment are, it's almost hard to deny that they'd both be involved in these type of traits. Now, some really controversial ones that I won't get into a lot, but intelligence and homosexuality, they don't have to do much with each other. But it's always being asked, for example, is intelligence just innate? You're smart or you're not smart. Are you born homosexual, or is that something that sort of happens for various other reasons? I don't have the answer, but all I can tell you is that it's becoming pretty clear that most likely there's both a genetic and an environmentalist to these and to pretty much all other so-called complex behavioral situations that exist in humans. Humans really are, you know, as much as we're animals, we have a lot more going on than animals. Um, your own thought patterns, your own free will, this gets a little philosophical, and that's why I'm not going to go there too much, can also affect your behavior and therefore almost cooperate with or fight against your genes, if you want to think of it that way. Well, my intent is not to be inflammatory here. It's just to let you know that while we know a lot about genetics, and certainly there's a lot to this, this is what the class is about. We just don't want to get too oversimple about it. We need to realize that, especially with respect to human complex traits, there may be a large environmental component. Okay, that's the end of this session. I'll see you again real soon.